The Alberta Council of Technologies presents feature keynote John Crawford of Cisco Canada, May 14th at 1:11 p.m. Watch live at bestofanalytics.com. John Crawford is a solutions architect for enterprise accounts with Cisco Canada. He joined Cisco in 2000 and has been responsible for driving innovative solutions across Cisco's extensive technology portfolio in many verticals including financial service, transportation, retail and government. Prior to Cisco, he was an enterprise architect for Tandem Computers, a leader in the online transaction processing systems. While at Tandem, he was responsible for the design and testing of large-scale online payment processing, fraud control and data warehousing systems.
There really is no limit to the types of things that we can put internet connectivity into. And more importantly, when you think about the performance of battery and battery technology, really the mobility and the ability to actually influence the use of internet-enabled devices is significant. So that $14 billion, we're trying to break it down. I'll give you some idea of where we think it is. It's probably about $2.5 trillion in better asset utilization, so the ability to actually refine the processes that business use and how they track and monetize and use the asset that they have available. It's an employee productivity. We're able to mine larger sources of richer data, and we're able to define better processes in the long run around how people interact, not just with between themselves, but between things on the internet, things within business. It's in supply chain and logistics, the ability for things to talk to each other, to logistically start to choreograph the supply chain in ways that we haven't been able to think of in the past. And then more importantly, it's in the customer experience and innovation. We think that the innovation wave is about to take off, and we think that that will drive significant benefit in the Internet of Things. And so the types of connections that matter most, it's still going to be the human-to-human, human-to-machine connection is still going to be 50 to 60% of where we think the internet is going to be in the future. But one of the fastest growing segments is going to be machine-to-machine, right? So things actually talking to themselves, being autonomous, but being able to make decisions through interconnectivity and information sharing. And so we're looking to this as a model for where we think the internet is going to grow to. Bringing it all together, turning information into action is going to be the challenge. We don't think that anyone's tried to scale to the size that we're talking about today. One of the challenges might be that 50 billion might be too small, right? So we're talking about some estimates here. We are sort of rolling it out in terms of a long-term projection. But typically when we've done that, we've undershot the mark, and so it could be small. But the challenge is going to be the number of devices, the velocity of what we're looking at, and the size of the entire data sets as we look forward. And so the technologies that we use to be able to tackle these problems have to change and have to change significantly. And so I give an example of two that we're currently working on. One of them is a continuous analytics architecture, the ability to put continuous SQL queries in the network devices themselves so that real time they can be pre-parsing the information and then sending those data sets back to larger storage for processing at a later date. And so we're looking at how far we can drive that into the network. Certainly one of the things that we see is that Moore's law allows us to grow network capacity. It also allows us to grow network intelligence, network capacity to actually put intelligent decision making in the devices that we create. And so we have the cycles, we have the processing capability, the capacity now to put intelligence down at the lowest levels of the networks and to start to pre-process the data that we're moving, even though the velocity is going to be greater and even though the amounts of data that we're looking at are going to be significantly larger in the future. Unified systems for scale and velocity. We think that the systems that we create for a compute perspective have to be able to scale differently and they have to scale more quickly. And so we're looking at rather building individual systems and then choreographing the management of those, that they have to be managed under a single image that allows us to actually very quickly break the system apart and then reorganize it on the fly so that we're able to tackle some of the challenges that we look at from the Internet of Things as we move forward. But in all of that, we believe the drivers are solid. Standardization of IP across all industries and across devices, we believe is there, that IP is ubiquitous and it is the only standard for interconnectivity. That mainstreaming cloud computing continues, and it gives us the flexibility to look at the very large data sets and the very high velocity information streams that we have to look at. The explosion and monetization of software apps is unstoppable, right? It is continually going to accelerate, and it's going to drive innovation, and it's going to drive the ability for us to use devices in ways that we've never seen before. We have to distribute intelligence, and we think we now have the capacity to do that in all the devices that make up the internet today. So we will see new management paradigms for the internet, we will see new architectures for the internet, and we will see new devices running within the internet, but we will see a lot more intelligence done inside the internet, actually doing the heavy lifting for us as we look at the number of devices expanding around the globe. And those devices will expand because we do know that network capacity can increase. We don't see any sort of barriers to doing that in the long term with network capacity, and we believe that we continue to drive the price down, and we're able to get network connectivity out to the rest of the world, those unconnected. So if we have 2 billion connected today, we believe that we can get 5 billion connected certainly by 2020, but more importantly, 50 billion additional devices in the small, unique machines out there that can be connected to the internet. And so amazing things happen when you connect things together, right? We've seen that in the last decade. It's amazing what can happen in our world when we actually connect to the internet. But what we've been able to connect so far is less than 1%, right? 99% of the physical world remains unconnected, and truly we believe it will be amazing when we reach out and start to connect all of those unconnected things in ways that we haven't been able to think of. That is the amazing part of the Internet of Everything. But one last thought, what will truly be amazing is the amount of data in flight or in storage that will be available for us to use. We'll be able to collect richer data from more sources across a greater network of interconnectivity that allows us to dig deep and find new ways to monetize and create value and to drive better interactions across the globe. And so that is the Internet of Everything, and I'd like to thank you for your time. And on behalf of Cisco Systems, thank you.
Do we have any questions for John? We have time here, have about 10 minutes or so. Yes?
Right, so primarily one of my focuses. Be happy to. So the question is privacy protection. So it's great that we can see an explosion of information and data within the network, but how do we deal with the issues of privacy, right? Certainly one of my primary functions in my day-to-day job is working with financial services where privacy is very important, obviously. What we're seeing is a general shift, actually, from what Gardner would call the data generators, which were us, people, right? We seem to be willing to open up the door to let more and more information out. And so it's very much an opt-in model is what seems to be pursued. So some of those examples I showed earlier with the Nest and with the Upband, they're very much opt-in models, right? So they allow you to decide, do you want to opt in? But there's always a value proposition, right? So the value proposition is you're going to have to give something up. So you have to give up some information, and you have some control over that. So it may there may be an agreement that it's aggregated information when it finally gets to its destination, but you agree to give it up, but there's a value in return, right? And so with Nest as an example, you give up information on the efficiency of your home and your energy usage, right? Although it's they agree not to personally tie that to personally identifiable geographic information, but in return, they give you information back from all the other users like you. So people in your geography, so that you can get a sense of just how well you manage your the efficiency of your home, for example. So I know in my house I have a smart meter, and for several years we've tried to be energy efficient. But when I look at Nest, it really has changed the tables. It gives you not just your view, and it doesn't show you just how well against some goal that you set for yourself, how well you're using energy. What it does is it ups the games. It shows you across North America or in Ontario or in your geography how well you're tracking against the mean and how efficient you're being, right? And so they have a small system called a green leaf. So you get a green leaf for every day that you do something that's energy efficient. There's no monetary value to that. It just gives you some indication of how well you're doing. But what they're doing is a value proposition. So you have to give up information, and in return, you get service. And so we see that as being the model moving forward, that ultimately, privacy is a significant concern, and we want to protect that as much as possible. But there has to be value creation in data exchange, and what we're starting to see is people are much more liberal now than they have been even in the last 5 years to be willing to do that, right? So, and app-enabled is sort of changing mindsets, it's changing the way we look at the privacy issue.
John, we'd like to thank you very much. It's a fascinating discussion. The scale of the growth of data is tremendous. And this whole idea of turning information into action, I think is really significant in terms of where we're going as a country and as a people. So I want to thank John for his time today. We have a gift for John from the organizing committee. So thank you so much, John Crawford.
Join the conversation next year as more cities become data-driven. Become a community partner. Contact us at info@abctech.ca.